Okay, welcome back to this lecture. We're going to talk about classes and structures, otherwise known as structs. And I've already started a new playground. I've called it Classes and Structures. So you can go ahead and do that right now. Pause the video if you need to. Once you have it open, I'm going to paste in some comments here as usual, and let's discuss them. So classes and structures, they're basically just blueprints that are used to create objects within your app, and it can be used to make copies of the same object. Essentially, they're just the building blocks of your entire app. You define properties and methods, increase the functionality of each of these classes, and make them do things that you want them to do. So everything we've learned so far, from a simple variable up to optionals and functions, all these type of things will go inside of classes most of the time. So let's go ahead and write one out. Let me do an example class. Let's call this, first you use the keyword class, and then you define the class, and you do it by using capital letters for each major word. So class, example class, then of course curly brackets, and inside of those curly brackets is where you put all the code you want to define your class. And just to quickly mention it, we're going to come back to structures at the end of this, but a structure would be defined as followed. Struct, and then I'll just call it example struct. And inside of those curly brackets would be, as you guessed, all the code that you want to define your structure. Okay, so let's get talking more about these because they are pretty critical to app development. So let's start with a simple class to give you the idea here. A simple class. Okay, first let's call this class. We'll call it expensive apartment. Okay, give yourself a little space there. Let's say within this class we have a variable called rent, which is an integer. Say it's $5,000. And within the class, we also have a function, and we'll call it the get rent price. We'll have that function return an integer. And here we're going to return, and we're going to do rent, but we need to use a keyword before rent. We need to write the word self.rent. And that self word means that it's referring to itself. So if you see self inside of a class, it means it's referring to the class. So therefore, it's referring to this rent variable within this class. Okay, so how can we use a class once we've actually made one? Well, here's how. Let's say we create a variable called my apartment. We can make it, right? We can make my apartment an instance of expensive apartment. So what that means is now my apartment can utilize anything that is within inside of the expensive apartment class. So for example, we have the get rent price. So let's go ahead and say my apartment dot get rent price. So it's going to use that function on itself, which would return the 5,000 as we expect. Okay, so here's a question for you. What if every time we make an object that is an expensive apartment class object, what if we want the rent to be different and not a static 5,000? Because that's more realistic in real life, right? Things would change. So how do we do that? Well, we would need to use what's called an initializer inside of the class itself. So let me show you what that means and how it's done. First, comment out the var rent equals 5,000, and instead replace it with var rent is an int. Next, after that, we want to initialize this rent variable. So to do that, initializer is the init keyword, and we're going to pass parameter of rent, which is of type int, through the initializer. And then we're going to say self.rent is equal to rent. I'm going to comment here that these are two different rents. So what I mean by these are two different rents is that one of the rents is the variable rent and the other rent is the parameter that will be passed into the init, which is rent itself. So they're two different even though they're the same word. So now, down here, we notice that the var my expensive apartment is causing an error. Let's go ahead and comment that out because that was from the previous version of the class. Now let's do it again. var my apartment equals expensive apartment, and now we need to throw in a rent number. Let's say 7,500. And now the my apartment get rent price will show the 7,500, which we passed through the initialization when we created the expensive apartment class. So if you need to, take a moment and pause and kind of see the flow of where data is entering and exiting through this class, right? We're typing in here, it's being initialized and passed right back out through the function getRentPrice, which the variable myApartment can use that function because it is an expensive apartment object. Right? So we could also, let's just say about var New York penthouse equals expensive apartment, rent is $25,000. It's actually cheap for a very nice New York penthouse. So now you can also do New York penthouse.getRentPrice, and it will show the $25,000. So that's a very simple example of how a class is defined and used when creating new objects. We will definitely see that, of course, in future lectures when we create some of our other apps. But now let's move on to structures. Okay, a structure. Actually, let me move this comment back up a little bit here, just so it makes a little more sense. Okay, and now onto structures. So a struct has stored properties which are constants or variables that are bundled up and stored as part of that structure. It's different than a class. So let's just do an example so you can see. How about this? Struct person height. Okay, now I don't know where you live across the world, but let's just pretend you are in the US for the moment. Here in the US, we measure a person's height by feet and inches, and both of those variables are necessary. If you're 6 foot, we would say you're 6 foot 0 inches, right? Or if you're 4 foot, we would say you're 4 foot 0 inches. We use both of them. If we're trying to get a person's height, we need both of those variables, so we might want to make a struct. Let's just define them as 0 each. We might want to use a structure to remind us that, hey, we actually do need to have both of these variables when we're defining someone's height. Okay, so that's a general use for a struct right there. You can also use structures within classes. So for example, let's say we make a class called person, and within that we have a few variables. Let's say there's name, which is a string. We have a var is married, it's a bool. We have a var age, which is an int. And we have a var height, which would be the person height struct. So I hope just with this very simple example of the struct, you see how it can be used, right? Because if we have a variable named height, we know that the height must have feet and inches. But just so we don't make a mistake somewhere throughout the app and disregard inches or feet, we have a struct in place to verify and confirm that we will wind up using both. So that is very simply classes and structures. So in the next lecture, we're going to talk about a very important topic, which is called inheritance. See you then.